Question number 23. A microphone, a stationary wave setup, sound wave is set up between loudspeaker and a wall. A microphone is connected to a CRO and is moved along a line directly between the loudspeaker and the wall. Okay, loudspeaker and the wall, right? And then the amplitude of the trace on the CRO. So this is your loudspeaker, this is the wall over here. Then you take a microphone over here. So this is the microphone, and then you start moving over here. This is your CRO, this is your wall. Okay. Amplitude of the trace on the CRO rises to a maximum at position X. At position X, let us say this is position X, it's at a maximum, falls to a minimum, falls to a minimum. So this is at maximum, falls to a minimum. Let me move my picture here. Falls to a minimum, this is your minimum. And then what happens? And then again rises to a maximum at position Y. So as you start moving here, it is a maximum once again here. So which means what? It is going to this point over here. Okay, which means between these two peaks is this X and Y. Okay, X and Y are positioned exactly at these two peaks. So as a result of this, what is the distance between them? Distance is 33 centimeter. He is already given this to you as 33 centimeter. Now usually when you have a wave coming up like this, goes like this and again goes like this. So what is the distance between these two? This is one crest. This is a crest and this is a trough over here. Distance between a crest and a trough is nothing but lambda by 2. So what is given to you? Lambda by 2 is given to you. So lambda by 2 equal to 33 centimeter. That's what you need to identify. Now when you take something in a CRO, you get a amplitude versus times, right? So therefore you need to find out the time over here. Okay. So because amplitude, there is no information here. Let us look at the time over here. So lambda is given. So lambda by 2 is given. Lambda should be equal to 66 centimeter. When it is 66 centimeter, frequency. What is frequency here? This should be V divided by lambda, which should be, how much is it? 330 divided by 66 centimeter. Okay. 33 tens up, 33 twos up, which should be 10 by 2, which is equal to 5 into 10 to the power of plus 2 hertz, right? Because centimeter converted into meter, 10 power minus 2 goes upwards to 10 square, which should be equal to 500 hertz. What is this now? This is nothing but frequency. Now how do I find time period here, right? Time period here, time period should be equal to 1 by frequency, which should be around 0.2. 0.2, is it 0.2? No, it's not 0.2. 1 by 500. Let me write it down clearly. Which should now be equal to 0.2 into 10 to the power of minus 2, or it is 2 milliseconds. Time period is 2 milliseconds. Now we need to find out where do we have 2 milliseconds here. See, where is time period in the CRO trace? Starting from here to here is one time period, right? Now it says 1 box, 1 centimeter equal to 0.5 milliseconds. So how many boxes are here? How many centimeters are here? 1, 2, 3, 4, 5, 6, 7, 8, which means there are 8 centimeters. So the scale here is 8 multiplied by 0.5, which is equal to 4 milliseconds. But what is the time period we got? 2 milliseconds. So definitely this is incorrect. Let us look at this here. What's the time period here? 1, 2, 3, 4. There are 4 here. 4 boxes makes one time period. 4 multiplied by 0.5 milliseconds will be equal to 2 milliseconds. So which is as required. So therefore B is the right answer. The rest of them also, if you want, you can try it out. You will get different values over here. If you want to do with this one here, 1, 2, 3, 4, 5, 6 from here to here, right? So 6 over here, 6 into 0.5 should be 3 milliseconds here. If you do here, this is 1, 2 over here, 1 full wave, right? So this should be 2 into 0.5, which should be 1 millisecond. So therefore these two, all the three are incorrect and B is the right answer. Okay.